Okay, this is going to be a super quick lesson on the law of sines because I already introduced this in the last chapter when we had not right triangles. So, that's just a little puzzle thing, so let's go to this one. So, look at the labeling here. This is important. The big A is across from the side called little a. The big C is across from the side little c. And this is kind of a convention that you'll see across all math classes, is generally the angles are big variables like capital letters. Okay, the corners on a shape would be capital letters, and the little sides would be lowercase letters. All right, now there is a cool way to find the area of this triangle, and I'm going to just jump right to it. There's a formula that you can have memorized that will give you the area of this triangle. You might be thinking, but isn't it just a squared plus b squared equals c squared? No, that's not even at all close, because that's the sides ratio, and that only works in a, what kind of a triangle? A right triangle. Okay, there's a new thing that's kind of like that that's called the law of cosines. And that one was, if you remember it, write it out here. It starts with a squared. It's kind of like that one. Let's see how good your short-term memory is on the law of cosines. Because there's really just three formulas you're going to need to know for this whole unit. The test is next Wednesday. And I feel like you're going to just knock this one out of the park because we've already practiced it a little bit. Did you say a squared plus b squared and then minus what? 2ab cosine c. All right. Equals c squared. All right. I suspect there is somebody that is not with me right now. I appreciate it if you get back with me. B cosine of big C equals c squared. Okay, then that one, just let me tell you, that doesn't tell you the area at all. But it does, it is a formula that's got angles and sides in it, and it's really handy if you either have all three sides but no angles. Do you get how this would allow you to solve for big C and you could get one of the angles? So this is useful when you have all three sides and no angles. There's another formula called law of sines. Does anybody recall it? It's a bunch of fractions. All right, then here we go. Sine of big A over little a equals, does anybody remember doing this? Yes. Yep. You got to get your capitals and your lowers like put together, because the capitals are the ones that are the angles. So for sine of big A makes sense, but sine of little a wouldn't, because little a is a side. All right, and I'll show you how to use these in a second, but I'm just going to add the last one, which is how to find the area of a not right triangle. The area will be A equals it's 1/2 base times height, except there's an extra thing thrown in, because remember, it's not a right triangle. 1/2, does anybody have this one memorized? All right, A, B, sine C. 1/2 AB sine C. All right, there's our three big formulas. You already know everything you need to know for the test coming next Wednesday. Now, why is it so cushy? Why is this such an easy chapter? Well, part of it is because we already talked about the law of cosines a fair amount on our last test. Could have been used on our last test. And we already have done non-right triangles before. So that was like a lot of our word problems had non-right triangles in it. We're also going to take a day, not a whole day, but we're going to take a day where we go out and measure the height of the commons using right triangles. Okay, so that's going to be a lab. And we'll just set up a thing in the commons where we can measure an angle, then move forward or move to the side, which is more complex. Move to the side and measure a new angle. And then when you have those two angles and how far apart you moved, then you can figure out the height of the commons. I don't expect you to get that whole thing from what I just said. I'm just trying to generally tell you what the height of the Commons Lab is about. So that's going to happen this week too. That's one of the reasons that it's kind of such an easy chapter. These are the three big formulas. If you know these three formulas and how to use them, piece of cake. All right, so let's go move on to, this is an example problem. Now, which one of my formulas should I use? Well, first of all, it's not asking me for the area. In fact, this one doesn't actually ask me for anything. But can you kind of guess what they want you to figure out? A and B, right? Okay, so then this must be not that area formula I just told you, but one of those other two. So which one? Law of, well, which one? I'll give you this hint. When you have a side and the angle across from it, either formula will work, but law of sines is easier. It's just easier. It's a big proportion. Okay, I'm going to write out the law of sines again. Sine big A over little a equals sine big B over little b equals sine big C over little c. And I'm going to figure out what I need to know and what I already do know. They've nicely used A and B here. Do you get these could have been called Q and R, and you'd have to relabel them as A and B, otherwise your formula won't work? Get what I'm saying? You got to meet because your formula's got A's, B's, and C's in it, you have to relabel it so it has A's, B's, and C. But they, on the first one, of course, start off nice. All right. Next, what's the one that's missing, but we actually have both parts? What letter is missing? Come on, participate. Goes better. C. Big C is here. This guy's little c. So that means I can fill this in my formula, right? I know big C, sine of C, sine of 110. And you use a calculator to get that because it's not something you'd have memorized. Over C, little c is 5.5, so I put that here. Equals, well, what other angle do we have? We already used up this, and we used up this. See what we got left there? Is that angle A or angle B? Big A or big B? Has to be big B because it's across from little b, so it must be big B. So big B is 20. So I'm going to put it right here. Sine of 20. Now, some people got confused because this is a triple fraction. Do you get all you really need is this part? Later, we'll set up a different one that solves for the A's, but there we go. This is it. Now, can you solve these by cross multiplying? Absolutely. That's probably the easiest way. This times this will equal that times that. And it'd be really handy if somebody would tell me these values because I don't have sine 20 memorized, for example. Anybody have sine 20 already? Could you take a calculator and type it in? Sine 20. You're going to need your calculator for this. So if you haven't already got it out, I'd get it out. Yes, ma'am? What'd you get? Anybody verify 0.34? Yes, thank you. Over, if you want to borrow one of mine, leave a shoe or a cell phone, and please bring your own next time. Over, I don't know what B is, so I put B. And sine 110. Type in sine 110, and what do you get? 939 is good enough. And then over B, over 5.5. Oh, cool. I just knew that one. So now, sloppy writing. There we go. And now this times this will equal that times that, and you solve. Would you please do that quick and then tell me what you get? 2 even? 2.00 something, which would probably mean it's a rounding error, so it's probably 2. I agree. Did you guys get 2? All right. If you didn't, try multiplying these out again. 0.34 times 5.5 should equal B times 9.937. I'm getting a lot of kids that got it right, so it must be 2, or round to 2. Okay, so there is your basic law of sines question. When do you use law of sines? When you have a side and an angle that are across from each other. Right there. Law of sines totally works awesome in this case because then it's just a little proportion. do you get how the other one is nastier to solve? A squared plus b squared minus 2ab cosine c equals c squared. It's much longer, and it's got to do inverse cosine in the middle of it. And law of cosines, though, is pretty handy if you don't have an angle and a side across from each other. Like, for instance, let's say that 5.5 was actually down here. Oh, wait, then I'd have a side and an angle across from each other. These two would be across from each other. All right, what if it was over here, though? Let's say the 5.5 was here. Then I don't have any side or angle. Oh, actually, I would, because then I could figure out this angle over here. There are instances, though, at minimum, I'll say this. What if I know all three sides and I don't know any of the angles? That is a scenario that comes up. I'm not saying this is even possible. But if this is three sides in a triangle, then the law of cosines will work and the other one won't. Okay. All there is to it is knowing three formulas. All right, so how would you solve this if it was a law of cosines question? You would just pick one side to be A, one side to be B, and one side to be C. And if you really want to save some time, if they're being asked this one, if they're being asked what angle is that, okay, or like if I call this C over here, then make the angle that you want to find, make that one called C, okay? And then you go, other ones are A and B, right? This one must be little c. This one must be A, and this one must be B, or vice versa. The A and B can switch because it doesn't matter. And you just do this formula. And you'd stick in what you know, which happens to be A and B and C, but you don't know big C. And then all you do is inverse cosine at the end to solve for that. All right, there. I've pretty much taught you the entire chapter today. And then from there, it's going to be easier yet. All right, your homework for tonight is to go do some problems that are like that. So let's find this. There are some weird things that come up called the ambiguous case. And yes, so there's something to learn in the next week. Otherwise, would that be wrong to spend a whole week on this if it was just that? There's a few things left. Did you find this slide yet? Find that slide. This is the first part of the homework. Now, notice they did not draw you a triangle. That means you have to draw yourself a triangle. And they used alpha. What in the heck? Well, they were trying to show you that you don't always have to have a big A and a little a, and a big B and a little b. But can you assume that alpha and A go together? Yes, you can. You can assume that. All right, so here we have an angle on the side across from it. You have to draw your own triangle that goes with it. And then your job is, of course, to find the other sides and angles in the triangle. We obviously have one of the angles and two of the sides. We want to know what the other side is and what the other two angles are. The first angle is the hard one, and after that you have 2 out of 3 angles in a right, or any triangle. You just subtract from 180. Piece of cake for the third angle. All right, so how would I do this first one? And I am assigning both 5 and 6. How would I do this first one? I draw a 117-degree angle. I don't know exactly what that looks like. I just know it's bigger than 90. And I'd call it 117. And then they gave me the side across from it, A, which is 35. And that's a setup for which one? Law of sines or law of cosines? Hint, the title of the lesson, Law of Sines up there. Okay, but so this is a law of sines question. And then I have one more. Side is 42. Does it matter which of these two it is? Nope. Because you can pick this to be A or B. It doesn't matter. I'm going to say it's the bottom one and call that 42 down there. Oops. Say this is 42. The other side, I don't know. And you need to figure that out. And you need to figure this out. You need to figure this out. And the first thing I'd start is by naming them. A's and B's and C's. I already know this one was big A, also known as alpha. This was little a. Let's call this B. Oh, it said B, so yeah. B is 42. And then that must mean this one's little c over here. And you figure out all the sides and the angles using the law of sines. Law of sines. Sine big A over little a. Sine big B over little b. Sine big C over little c. By the way, sometimes you see this formula written upside down. It's totally okay. You get if you flip all three fractions, it'll stay equal. Would that make sense to you? You can just flip them all upside down if you want to. All right. So sine of A, which in this case is 117, and then little a, which was 35. And then let's just do the B one, because it's right next door. And we'll just use this part of the formula. Do we know angle big B? No, but we know side little b is 42, so we put a 42 here. And this reminds me to tell you, you don't always have to cross multiply to solve these. Do you get, if your only goal here is to get sine B alone and then do inverse sine to like finish the job? Your main deal here is you'd multiply by 42 on both sides. Okay. I feel like we're on track, doing, you know, like I think you could handle this. You want me to finish this? Okay, tell me what sine 117 times 42 is. Sine 117 times 42. Hold on, equals sine B times 35. I'm cross multiplying, I'm doing it that way. Now I'm going to divide by 35. Anybody verify this? 1.06? Yes or no? Okay, thank you. And then, how do we finish it from there? Do you remember how to do the inverse to get this? Ah, okay, okay. This is a good point. This is an example right off the bat of the ambiguous case. All right, what that means is that 42 couldn't be where we put it. Do you get we had two choices on where to put it? That 42 must have actually been over here on the other side. How can you change it? You just... It wouldn't change the formula, but... All right, I'm going to pause for a second and check something. Okay, so here we are. I'm looking at the key. That's why it's not working, because this is one of those ambiguous cases. And I was telling you before that there is one tricky situation we're going to have to eventually cover, and that is the ambiguous case. We will talk about that more later. So instead, would you, I'm not even going to sign number 5. You already know the answer is that this one's impossible. I'll show you more about why tomorrow, because that's the last thing I really have to teach you in this unit, is you can't just always construct triangles given an angle and a couple sides, because sometimes you can't make a triangle like that. There's no way to make a triangle where there's a 117-degree angle right here, and this side's 42 and this side's 35. It's just not possible. Like, you can't do it. So I will show you more about why that is. Basically, one of the sides isn't long enough to make this work. If this side of 35 was a little longer, then you could actually make a triangle like that, but you can't. All right. So then when you get one, for future reference, that's like, oh, I'm using the formula right, I know I'm doing everything right, and it's not working, then what's the answer? No solution. Okay. All right. So I am going to assign 6 and scroll down a little bit. 9 is another ambiguous case, so we're going to go with 10. 6, 10, and 26. 6 and 10 and 26. Those are the 3 I want you to do for tonight. Again, do you have to know this all by tomorrow and be an expert on it? No. When's the test? Next Wednesday. You don't have to be a boss at this yet. All right. I'm going to stop the video for today, and I'm going to hand back some tests.